Hey team, it's Mr. Z, and today we're going to do activity 1.2, which is all about end behavior. Okay, end behavior, we kind of touched upon it last time, of a graph is the behavior of the graph as it approaches infinity and negative infinity. And what it's saying, as x approaches infinity, what this is really kind of saying is, as x goes to the right, what is the output? So you're scanning to the right, and you can see as it goes right, it is increasing. As x approaches negative infinity, goes to the left. Negative infinity is a negative value that is so large, and essentially you start from the origin and you look at it going to the left. Notice it is decreasing. So this is the formal format. We are going to touch upon this more. This translates as x is going to the right, f of x is pointing to positive infinity. As x is approaching the left, it is pointing down to negative infinity. Remember, these arrows represent infinity. So we're going to consider the graph shown below. Oh wow, linear, quadratic, cubic. What happens when the a value is negative? Write each function in terms of x and sketch it. So if you want to pause and read the remember, the a value is when you multiply it to the outside. This is going to cause a reflection across the x-axis. So negative f of x is going to result in negative x. What is that going to look like? Well, I'm going to flip the above graph. It is going to reflect across the x-axis. So the line will look like so. Notice here, it is on the opposite side. Notice this part is positive. Now it's negative. I'm going to do the same thing for this next guy. I'm going to multiply it by negative on the outside, so it's going to be negative x squared. So what is this going to look like? I look at the left side. It's going to reflect. It's going to be facing the opposite direction. And likewise, the opposite direction. Notice, concave down is a reflection. Continuing, the negative is in front. The left side, right now the current behavior is as x approaches negative infinity, it's pointing to negative infinity. So I want it to be reflected and vice versa. So all I did was reflect the power function. Notice what happens when a is a negative value, when the number in front of a function is negative. That means it is going to be a reflection across the x-axis. What happens when the b value is negative? Now notice on the inside. What basically happens is the difference here is you're going to plug it in for the x value. And this is going to be on the inside. Notice how before it was just negative 1 times x squared. Here it was negative 1 times x to the cube. Now the negative's on the inside. So there's a slight difference. When you simplify this, this is just going to be negative x. So it's going to look very similar. It is going to be a decreasing line. Notice how it's going to be a reflection across the y-axis. My original guy, this guy, is going to go over here, and this one is going to go over here. going to be a vertical reflection. Likewise, negative 1x squared. This simplifies into a negative x times a negative x. Which is the same thing as just x squared. So it's going to look the same. And you might be wondering why. Well, let's look at our original graph. The green side will go over here, and the yellow side will go over here. Well, since it's symmetrical anyway, there's going to be no change. Now, negative x cubed. How many negative x's am I going to have? Well, that's going to be 3. Think back to our negative rules. A negative times a negative is going to be a positive x squared. Being multiplied, a negative x, is going to result in a negative x cubed. Notice evens, it's positive. Odd, it's negative. So negative x cubed is going to be this graph flipped across the y-axis. This is going to go here. This is going to go there.